Hello and welcome to the vodcast about combination and decomposition reactions, the word and chemical equations. First of all, we'll tackle combination reactions. This is when molecule A is added to molecule B and we get molecule AB in that they are joined together. So two become one. To do the word equation for a combination reaction, first write out the words for the reactants. Then draw the arrow that represents the reaction. Then write out the product in word form. For the chemical equation, write out the symbols for the reactants. Don't forget to include the phase, which means are they solid, liquid, or gas. Then draw an arrow to represent the reaction, and then write out the symbol for the product. Don't forget to include the phase, solid, liquid, or gas. Then balance the equation by changing the coefficients. The Haber process is a very famous combination reaction. Nitrogen gas is reacted with hydrogen gas to make ammonia gas. So first we do the word equation. Nitrogen gas plus hydrogen gas equals ammonia gas. Then comes the chemical equation. Nitrogen gas is N2, and in brackets we write G for gas, plus H2 for hydrogen, and again in brackets, a lowercase g, which means it's a gas. Then the arrow to represent the reaction, and then ammonia is NH3, which again in brackets we have a lowercase g, because ammonia is created as a gas. To balance the equation, all we can do is change the coefficients. So if we look at the products here, we've got NH3. So hydrogens obviously come in 3s, but in the reactants they come in 2s. So if we put a 3 in front of the H2 and a 2 in front of the NH3, then we end up with 6 hydrogens on each side. Also now we have 2 nitrogens, and nitrogen gas is N2. So everything is now balanced. We've got the same number of nitrogens and hydrogens in the reactants and the products. Then we go on to the decomposition reaction. This is where one molecule is split into 2 or more molecules. So the steps to doing a decomposition reaction. First of all, we'll do the word equation. So we're going to write out the reactant, then draw an arrow, and then write the words of the products. For the chemical equation, we're going to write out the symbol for the reactant, and we're going to include the phase. Then we're going to write out the symbols for the products. Don't forget the phase is whether it is solid, liquid, or a gas. Then we're going to balance the equation by changing the coefficients. A classical decomposition reaction is the decomposition of hydrogen peroxide. Hydrogen peroxide, which is a liquid, decomposes naturally into water, which is a liquid, and oxygen gas. So the word equation is hydrogen peroxide with an arrow for the reaction turns into water and oxygen gas. The chemical equation is H2O2, which is a liquid, arrow, gives us H2O, which is a liquid, plus O2, which is a gas. To balance the equation, all we can do is change the coefficients. So if we look at the products, we can see that we've got 3 oxygens. We've got 1 in water and 2 in the oxygen gas. Therefore, we know we have to increase the number of oxygens in the reactant. So if you put a 2 in front of the H2O2, we know we now have 4 hydrogens because 2 times 2 is 4 and 4 oxygens. So in the products, we now need to make sure we've got 4 hydrogens and 4 oxygens. By putting a 2 in front of the H2O, we now have 2 times 2 hydrogens plus 2 times 1 oxygens in the water and 1 times 2 oxygens in the oxygen gas. So in the products, we have 4 hydrogens and 2 plus 2, which is 4 oxygens. Now the equation is balanced. Thank you for listening. Thank you for paying attention, and I hope you've learnt something. Like and subscribe if you like, and I'll catch you later. Bye now.